Hi, welcome to the third class of CSEC Chemistry at Edu Solutions Institute. Today we'll be continuing with mixtures and we'll be focusing on separating techniques. Separating techniques has to do with separating the different substances that were used to make a mixture, right? So in doing this, it has to be based on different properties. What are some properties that we are going to distinguish between the substances that we are able to separate? It could be their solubility, especially in water, could be their boiling point, or it could just be their density, how high or light or heavy they are. These properties help us to separate different substances when we have a mixture. For example, let's say we made salt in water, right? How do we get back some of those salts from the water that's already mixed together, right? And so we're going to look at some of the popular separating techniques that the syllabus wants you to cover. These separating techniques are the simple distillation. And here is a picture that shows the setup of a simple distillation apparatus. Here we see that in the simple distillation, we have a substance that's in this conical flask, right? This substance, they are mixed together, they are soluble, right? So we're not seeing the different components of this mixture. But when we heat it, in simple distillation, what it does is to ensure that these substances have very wide boiling point, right? So first property, boiling point. So because their boiling points are extremely far apart, when you heat it, the one that reaches boiling point first will start forming vapors. These vapors will rise up through the conical flask and can be condensed through this, right, into a separate separate container, preferably a beaker or another conical flask. So here we see that simple distillation is used to separate substances that have very wide boiling points. And these substances are actually mixed or soluble with each other. Alright, so the one that has the lowest boiling point will evaporate, get condensed, and collect into a separate container. Then we have the fractional distillation. And here we have a setup of the fractional distillation. Now, it is similar to the simple distillation, but it's used widely for substances where their components are very close in boiling point, right? And that's why we need a fractional column. The fractional column collects these substances, right, that their boiling point are closely related. So the first one, when you reach that boiling point, evaporates with collected at the top. Then the second one gets collected below that, and it continues to fill those different columns, right? And then these now go through what we call the Leipzig condenser, right? Which is purpose is to condense these vapors to our liquid so we can collect them in separate containers. So it's similar to the simple distillation, but this one is more unique to separating substances where their boiling point are similar, very close to each other. All right. Then we look at our paper chromatography. Now, your paper chromatography is used to separate pigments. Pigments are colors, right? So we know that when we see a specific color, like this blue here, it's made up of different colors mixed together to give you that specific blue. And what's the separating method of paper chromatography does is to separate these pigments into their different colors that was used to make this specific color, right? So in this case, if I want to know what colors were used in making this black marker here, right, I would simply put a dot on the paper at the base of the paper here, right, and I drop some ethanol, like 2 drops of ethanol. Now the purpose of the ethanol is to get the mixtures to mix with the ethanol. Right? So the ethanol will be your solvent. They're going to dissolve within the ethanol. Now I put this paper into now a mixture of ethanol or water, right? So barely where the ink is, that part is only in the solution, right? And then over a period of time, the different colors will start to rise up the paper. They're rising up the paper because that liquid that's in the beaker starts to go up the paper. And going up the paper will mean it's taking those different colors with it. Now, why the colors are separate? The colors are separate because the density of those colors are different. So in cases, the blue will have a different density than orange or red. So therefore, you see them separate because of their density as well as their solubility in that specific, right? So their solubility and density affects how high they will go up the paper. And hence, from the look, you'll be able to see which substances are present in that specific pigment. Then we go to our separating funnel. Now, a separating funnel is where we use liquids that do not mix. These liquids that do not mix, they are called immiscible, right? So immiscible liquids, liquids that do not mix. Example, oil and water, right? So let's say you have your last drip of cooking oil and it somehow end up in some water. How can we separate? But just by the look of oil and water, the oil settles at the top, the water settles at the bottom due to their different densities, right? So therefore, the separating funnel, all it does is to give us that opportunity that we can drain off the dense part into a different container so we can leave the less dense one into the funnel, right? So it's a barely turning the tap until all the dense one, in this case would be water, comes out into the separate container, and then we close off that tab to ensure that both liquids are now separated. And finally, the popular filtration method. Now, the filtration method is a simple method of separating things that they don't fully mix. So it begins with their solubility. For example, sand and water. If you mix sand in water, you're still going to have those grains or particles of sand settling at the bottom because they don't fully mix in water, right? So if we want to separate the water, then all we're doing is we're pouring that mixture down through this funnel that has coating of filter paper. The filter paper purpose is to strain the filtrate, which is the part that's coming through it, right? Which in this case would be water, and leave back the bigger particles that can pass through the filter funnel, which are called the residue. So the filtrate gets collected in a separate beaker, right? And the residue, which would be the sand, will left within the filter paper, right? A separating method that's not listed here is about crystallization. Crystallization has to do with you heating up the substance, allowing the liquid part of that mixture to evaporate, and it leaves back the crystals of what was mixed with it. So example would be, salt and water. So we can evaporate the salt, the water, and the salt will remain as a crystal after you cool it, right? So that's also a method that's used in separating substances. So as you can see with separating techniques, it's dependent on different properties, right? As well as choosing which method is suitable for which mixture that you're hoping to achieve the separation for. So thank you for looking at our next lesson. Alright, so next week we'll continue our syllabus, and this was a lesson based on separating techniques. Hope you learned something today. See you next week. Bye.